All right, so you're a developer, right? You've played around with machine learning, maybe in a Jupyter notebook, but you've hit that wall. How do you go from a cool script to something real, something that actually works in production? Well, that's exactly what we're tackling today. We're going to lay out a complete production-ready workflow, pulling the best ideas from the India AI Summit.
You know, this quote just hits the nail on the head. Anyone can throw a model together in a notebook. That's the easy part. The real challenge, the part that separates the pros from the amateurs, is building something you can actually trust. Something that doesn't just work once, but works reliably every single time. So yeah, let's dive in and see how we actually do that. Okay, here's our game plan. We've got 5 simple steps. We'll start with a baseline, then figure out how to evaluate it like a pro, boost its performance, make sure it's reproducible, and finally, tie it all together.
All right, first things first, we need to build a baseline. Think of this as your hello world for machine learning. Before you even think about some giant complex neural network, you need a simple working model. Why? Because this little model becomes your measuring stick. Every fancy thing you try later has to beat this baseline. If it can't, it's not worth it.
So where do you even start? Seriously, forget about the big flashy deep learning models for a minute. The experts are all saying the same thing. Start simple. Start transparent. Something like a logistic regression. I mean, it's lightning fast, and it practically tells you, hey, this feature is important and this one isn't. Or a decision tree, where you can literally see the flowchart of how it makes decisions. That's huge for debugging. Here's the real secret, though. These simple models are like an early warning system. If your data's a mess, they will let you know loud and clear, saving you from a world of hurt later on.
Okay, you've picked your simple model. Now you gotta test it, right? And yeah, everyone knows you split your data into a training set and a testing set. That's ML 101. But look at this little bit of code. This is where things get serious. The parameters you use here are what elevate your project from a quick experiment to a professional, reliable system.
Let's zoom in on these 2 parameters, because honestly, they're absolute game changers. First up, stratify equals Y. Okay, picture this. You're predicting which customers are going to cancel their subscription. It's a rare event, maybe only 5% of your users. If you just split your data randomly, you might get super unlucky and have a test set with, well, no churning customers at all. Your model looks great, but it's a complete lie. Stratify prevents that. It makes sure your test set has the same 5% ratio as your original data. It's critical. Then you've got random state equals 42. This is your sanity check. This little number ensures that every time you run this code, the split is identical. Your coworker runs it, same split. The deployment server runs it, same split. It kills the, well, it worked on my laptop excuse forever.
Okay, so we have a baseline model. We've split our data properly. So, is the model any good? That's the million-dollar question, right? And the answer isn't always obvious. So let's talk about how to evaluate it like a pro and go way beyond just looking at basic accuracy.
So I ask you this, your model hits 90% accuracy. Is it ready to ship? This is the classic trap everyone falls into. And I mean everyone. Let's go back to that customer churn example. If 90% of your customers stay with you, I can build a model that's 90% accurate right now. It just predicts stay for everybody. See the problem? It's technically accurate, but it's also completely, utterly useless. Accuracy can be a total mirage.
So here's the pro move. You've got to look beyond accuracy. It's about using the right metric for the right problem. If your data set is perfectly balanced, sure, accuracy can be fine. But for pretty much any real-world problem, like fraud detection or predicting churn, you need something better. The F1 score is your best friend here. It's a smart combination of precision and recall, and it tells you how well you're catching those rare events you actually care about. Then there's ROC-AUC, which is a great way to see how good your model is at distinguishing between the good and the bad. Using these together gives you the real story, not just a vanity metric.
And this visual here, the confusion matrix, is your best diagnostic tool. It's so much more than just a single number. It shows you the types of mistakes your model is making. Look at those false negatives. In our churn example, those are the customers who were going to leave, but your model said, nah, they're fine. Every single one of those is lost revenue. That's the kind of critical business-level insight that a simple accuracy score would completely hide from you.
Okay, so now we know how to measure performance correctly. The next logical step is to, well, make it better. But we're not just going to randomly poke at the model and hope for the best. We need a system.
And that system is all about automating the boring stuff. Every model has these little knobs and dials you can turn. They're called hyperparameters. You could spend weeks manually tweaking them, or you could be smart about it. That's where a tool like Grid Search CV from Scikit-learn comes in. It basically takes the endless manual trial and error and turns it into a simple, automated 3-step recipe.
So how does this magic work? It's actually pretty simple. You create what's called a param grid. Think of it like a shopping list of all the different settings you want to test out. Now, a little tip here. Don't go crazy. Maybe pick 3 or 5 options for each setting. Because what Grid Search CV does is it takes that list and methodically tries every single combination. It's a brute force search for the best setup. Yeah, it might take a bit of time to run, but when it's done, you'll know you've found the best possible settings from your list. No guesswork involved.
Okay, this next part is for all my fellow developers out there. It's a word we live and breathe. Reproducibility. Let's be real. If you build an amazing model but can't build it again, you didn't create an asset. You just got lucky once. We need a reliable, repeatable process.
This is where experiment tracking comes into play. And honestly, if you're not doing this, you're flying blind. The best analogy is it's like Git for your machine learning experiments. Instead of just letting your results fly by on the screen, tools like MLflow or Weights and Biases will log everything for you. The code version, the parameters you used, the final metrics, even the model artifact itself. All of a sudden, you have this incredible, searchable history. You can go back and see, oh, that's the change that boosted my F1 score. Or yikes, that's what caused the performance to drop. It's essential.
And I love this piece of advice. It's so important. Start doing this from day one. Don't wait until your project is some huge complex monster. Log everything, even your first basic runs. Because building that habit and that history early on will save you from so many headaches down the road. Trust me.
The other pillar of reproducibility is the ML pipeline. And the best way I can describe it is, it's like a Docker file for your model's entire workflow. You know all those little steps you have to do? Clean the data, scale the features, maybe fill in some missing values, and then finally train the model? A pipeline wraps all of that up into one clean single object. This is an absolute lifesaver for making sure your production code doesn't have weird bugs that your training code didn't.
And just look at how clean this is. You literally just list the steps in order. But the real magic isn't just that it's tidy. It prevents one of the most silent and deadly bugs in ML, data leakage. That's when information from your test set accidentally contaminates your training process, making your model look way better than it actually is. Pipelines make that basically impossible. And when it's time to go to production, you don't have a bunch of scripts and objects, you have one pipeline object. You call .predict on it and it handles everything in the right order every time. That's what being production safe is all about.
All right, we've covered a lot of ground. Let's put it all together now and look at the complete workflow, start to finish. So here it is, your complete checklist, your roadmap. Number 1, start with a simple baseline. 2, split your data correctly using stratify and random_state. 3, evaluate with smart metrics like F1 and ROCAUC, not just accuracy. 4, optimize your model systematically with something like Grid Search VC. And finally, number 5, ensure it's all reproducible with pipelines and experiment tracking. This is the process that takes you from a simple script to a professional-grade ML asset.
And there you have it, a process that gives you a high-performing model you can actually reproduce and trust. But of course, that just leads to the next big question, doesn't it? How do you actually get this thing out there, serving predictions to potentially millions of users in real time? Well, that, my friends, is the giant world of ML apps, and it's a story for another day. Hope you found this useful. Thanks for tuning in.